So hi guys, I'm here. Now this is a video that I talked to you about on clarifying one of the phenytoin PK questions that appeared on our exam. Now you may notice that this question was also the same one that we reviewed in our lecture. So this is a question on calculating the time it takes to decline to a certain level of phenytoin serum concentration. So this is a question, and you may recall it from the exam, which was yesterday. And first step was, of course, to calculate the patient's specific VM, which came out to be 421. And based on this equation, we are plugging in order to get the answer. So in doing this calculation, first step is you do 27.6 over 15. You get the answer from that and take natural logarithm of that number. After that, you'll be multiplying it by the Km, which is 4, and then you add the difference between the observed concentration and the expected concentration. And you do that, and you divide it by whatever you get from the denominator, which is right here. So the answer is 1.7. Now, what I had on my previous lecture slide did not convey this particular order of calculation. So now I posted a revised form, and it will be reflected as this way. So you do 27.6 over 15, take the natural log, multiply it by the Km, and then you add the difference between the two concentrations. That's your numerator, and you divide that by whatever you get from the denominator. The answer will be 1.67 days for this particular problem. Now, one thing I wanted to go over with you was from the lab yesterday. So yesterday, the section 91 had their lab, and it seems like some people were not able to get to, right, in terms of consensus of the number of days it takes for the concentration to drop. So in this lab case that some of you guys had yesterday is this patient, elderly patient who had phenytoin level of 15 milligram per liter, but with his low albumin taken into consideration, his adjusted level was 21 using this particular equation. How do I get that 21? Based on, so I took the 15, which is the observed concentration, and then the denominator was 0.9 times 3.0 over 4.4 plus 0.1, and so the whole thing was the denominator, and my adjusted phenytoin level was 21 milligram per liter. Now with that, I calculated, let's see, patient-specific VM, which was, well, he was taking 300 milligram of extended release daily. So that was his daily dose. So 0.92 was your salt factor by availability, and then the daily dose. And then I plugged in basically what I had. So VM is here, 21 is the observed, the adjusted phenytoin level, 4 is the Km, plus the adjusted phenytoin level. So patient-specific VM came out to be 329 milligram per liter. And I calculated the patient's specific volume of distribution. So 0.69 times patient's weight, which was 50 kilos, came out to be 32.5 liters. And I got this equation, right, for the time it takes to drop the concentration to 15 milligram per liter. So this is how I plugged in. So it was, I took the C1 is the adjusted level, 21, and C2 is where you want to get to, which is 15. I want to get to 15, and I want to calculate how long it takes for the concentration to drop from 21 to 15 milligram per liter. So I plugged that in, and I took the natural logarithm of 21 over 15, multiply that by 4, which is your Km, and add to the difference between C1 and C2, which was 6. That was my numerator. My denominator was VM, which I calculated above, divided by the volume of distribution. When I did that, I got 0.7 days. So based on that calculation, what I decided to do for this particular case was hold phenytoin for 1 day, since he gets it every day, once a day, and everything all together. And then I calculate the new daily dose, but that was using this particular equation. So all that to say that the order of calculation for when you calculate the time of decline, it will be you make the fraction of C1 over C2, take the natural logarithm of that fraction, multiply Km, and then you add the difference between C1 and C2, divided by Vm over Vd. So hopefully that order of calculation is clear to you. So if you need more practice, you can work with this particular lab case that I gave to section 91 yesterday, and hopefully this can clarify some of you guys in terms of calculating the time of declining. Okay, well, thank you.